In this video, we're going to be looking at the second half of lesson 9.1 on areas of triangles and quadrilaterals. If you haven't already completed the 9.1 day 1 notes, you should do that first. In day 1, we looked at how to find the area of rectangles, parallelograms, triangles, and trapezoids. In day 2, we're going to focus on 2 more special quadrilaterals, and those are rhombuses and kites. So you calculate the area of a rhombus or kite using the formula area equals 1/2 d1 times d2, where d1 and d2 are the lengths of the full diagonals. So if the diagonals are divided into sections, you'll need to add the sections to find the lengths of the full diagonals. And we'll look at an example like that in just a moment. Another way that you can write the formula for the area of a rhombus or kite is instead of the half, you can just do area equals d1 times d2, and then divide that result by 2. Dividing by 2 is the same as multiplying by a half. So in our picture here, the first shape is a rhombus, and the lengths of the diagonals, d1 would be all the way across, and d2 is all the way across the other way. Similarly, in the kite, d1 is one of the full diagonals, and d2 is the other. So now that we have our formulas down, let's go ahead and look at a couple examples involving finding measurements of rhombuses and kites. The first thing we're going to do is calculate the area of this kite. And to calculate the area, we can use that formula that we just wrote down, area equals 1/2 d1 times d2. Here, though, we need to do some calculating before we figure out the calculation. D1 is one of the diagonals. It doesn't matter which one's D1 and which one's D2. So D1, I'm going to let be the 12 plus the 12. So D1 is 24. Then we'll do the same to calculate D2. So D2 is that second diagonal. And notice how that is 20 and 12. So I need to take 20 and add 12, and that's 32. So those values there, the total lengths, are what we need to use for the diagonals. So now let's go ahead and substitute those values into our formula. Area equals 1/2. D1 was 24, and D2 was 32. And if you go ahead and calculate that, 1/2 times 24 times 32 ends up being 384. And when you're typing this in your calculator, it's fine to change the half to 0.5. Or remember, if you want to, you could also do 24 times 32 first, and then get a number for that, and then divide it by 2, and you'll get the same answer in the end. Let's make sure, though, that our final answer includes the appropriate unit. Since there's no unit given in this problem, we can just say units squared. Doesn't tell us it's inches or centimeters or anything. So we'll say units squared, or U squared for short. Let's try another example. For part B, we have a kite that has an area of 48 square centimeters, and the length of one diagonal is 16 centimeters. Find the length of the second diagonal. We still want to use the area formula for a kite, which is 1/2 d1 times d2. So this time, we know the area is 48. So I'm going to substitute 48 right here. And then D1 is the 16. And D2 is our unknown. When you're multiplying, you can just kind of go in whatever order you want. So since I have the 1/2 and the 16, let's just start by multiplying those together. They make 8. So 8 times D2 has to equal 48. Well, now if we just divide by 8, that gives us D2 equals 6. So the length of the second diagonal is 6 centimeters. So these two examples have both been kites. In the next example, we're going to look at a rhombus. Remember that rhombuses and kites have the exact same area formula. Area equals 1/2 D1 times D2. So in this problem, we are given the perimeter of a rhombus is 54 centimeters and the length of one diagonal is 10 centimeters. This is a really good problem. I would star this. I know you're going to see one like this on your CYU. You'll also probably see a similar question to this on a future quiz or test. Now, the key here is that this is a rhombus, and we know that in a rhombus, there are 4 congruent sides. All 4 sides are the same. So if we know the perimeter is 54 centimeters, it tells us that in the problem, we need to just divide that by how many sides there are. So I'm going to take 54 and divide that by 4, and that's 13. So each side in our rhombus is 13 centimeters. So now let's see what else we know. We're given in the problem that one diagonal is 10 centimeters. Let's just pick one of those diagonals to be 10 centimeters. Remember, though, that the full diagonal is 10 centimeters. Let's think back to what we learned last unit. In the previous unit, we learned that a rhombus is a special parallelogram. And in all parallelograms, the diagonals bisect each other. So if the full diagonal is 10, let's take 10 and divide it by 2, and that's 5. So each of these sides here would be 5. Another property of a rhombus, not only are all sides congruent, but in a rhombus, the diagonals are perpendicular, which means they intersect to form a right angle. So now we essentially have 4 right triangles. 1, 2, 3, 4. Let's just kind of narrow in on one of those triangles. And notice that in that right triangle, we have the hypotenuse, 13. So that's going to be my C. And then A and B are the other two sides. So let's go A squared plus B squared equals C squared. That's our Pythagorean theorem. And then I'll let the A just be X right here. So X squared plus 5 squared equals C squared, the hypotenuse squared, which is 13 squared. Now let's just do our calculations. 5 squared is 25. 13 squared is 169. We'll subtract 25 from each side to get x squared equals 144. And now we can undo the squared by taking a square root. The square root of 144 is 12. So this is going to help me now to find the length of the other diagonal. 12 is half of that diagonal. So for the length of the other diagonal, I guess I'm going to just move a little bit over here because I'm out of space. So the second diagonal is the 12 plus the 12, or 12 times 2. So the second diagonal would be 24 centimeters. And now that we have that, we can go ahead and calculate the area of the rhombus. The area formula for a rhombus is the same formula we used for the kite. Area equals 1/2 times D1 times D2. D1 we were given in the problem. That was 10. And D2 is the 24 that we just calculated. You can multiply these in order from left to right, or remember, you can also just multiply that and then divide by 2. So I'm going to do it that way this time. So that's 240, and then half is the same as dividing by 2. So 240 divided by 2 is 120. So our area of the rhombus is going to be 120 centimeters squared. This concludes lesson 9.1. Now you know how to find the area of triangles and the area of the special quadrilaterals. The quadrilaterals that we've covered in this section were parallelograms, rectangles, trapezoids, rhombuses, and kites. So thanks for watching and good luck as you practice some areas.